Hello friends, good evening. This is Sundaresan and Arun Kumar, Civil Engineering Department of Congo Engineering College. We are here to present a slide or video which is regarding the foundation engineering. Means basically it is not that a civil engineer or a structural engineer must know about the foundations, but it's the common man who needs to build a structure or a building. He needs to know what is a foundation and what are the types of foundation and what type of foundation is suitable for his building. So for that, we have created a slide presentation so that maybe a layman also can know what are the types of foundation and what is its advantages or like that. So let us start our presentation now. So what is the function of foundation? First of all, we must know what is a foundation. So first, the foundation is the thing. We can say it's a structural element which transfers the load from building to the soil below. Okay, so we know that we are standing in a ground. If our foot is not spreaded over, then we can find we can't be stable. Means our body will not be stable. So our body's load is transferred to the ground by a distributed footing. Like we can say it is the foot. Likewise, our building also must distribute its load in a very large area so that it will be very stable. So for that we need a very good structure. It is called as the foundation. Okay. So now let us go inside the foundation type. But before that we must know what are the components of a building. So basically we say that above the ground level it is the superstructure and below the ground level it is the substructure. Okay. So in substructure it comes uh, it has that foundation and footing. Okay. So we'll see the next thing. So foundation, it is broadly classified into two main divisions, which is shallow foundation and deep foundation. So when we say it is a shallow foundation and when we say it is a deep foundation, there is a relation. Suppose we have a foundation of size L into B, maybe the lower dimension is B. So that lower dimension to the depth of the foundation, if it is less than 1, then we can say it is shallow foundation. It means that when the depth is less than its breadth or the minimum dimension, then we can say it is a shallow foundation. But deep foundations are those which the depth is more than the lowest dimension of the foundation. Okay. So what are the advantages or what distinction are there between these two foundations are? These shallow foundations can be suitable for soil where the load carrying capacity is very more. So we can say when the load carrying capacity is much more in a soil, then we can go for a shallow foundation. But when the load carrying capacity is very low, means what is the load carrying capacity? First of all, it is the load per unit area that the soil can resist without any failure. Okay. So uh, just we can imagine, uh, if there is a loose soil, then we can't walk very fastly, so we need to go very slowly, which means what is the reason behind this? So there are loose particles in the sand. So to when our foundation is placed in this sandy soil, what happens? There may be settlement in our foundation. So there is a need that we must avoid this loose particles. So what in general, according to geology, the geological nature of earth, there is deep rocks inside the core of the earth. So we need to go very deep for our foundation so that the load from the building or structure, it is not directly transferred to the ground in the surface, but it is transferred very deeply by the modes of some special foundations. We can say like pile foundations, like that. Okay. So these are the two types. So in shallow foundation we can see that column foundations without we can say tie beams or bridge beams. So in deep foundation it is like piles or caissons, like that. Okay. So what is the solar foundation? As I already discussed, is there. So in solar foundation we can say it's a mat foundation. So mat foundation is a thing that which covers the uh, whole area of the plan view of the structure, so that it acts like a slab below the ground. So when we load a slab, what happens? You can imagine two situations, like if you just pinch, if you just press, we can say, we can do an exercise here. Take a pen, take a pencil or a pen, just punch the sheet or a paper, what happens here? So due to the very less area in the nib of the pen, the paper tears off or the paper gets punctured. But now the second situation, reverse the pen and just do the same activity. What happens here? So the paper doesn't get punctured. So what do you find the results? So when the area is very less, so it punches the paper. But if you consider the second scenario, when the uh, rear side of the pen, it has some very little good area, there you can it doesn't punches the paper. So the same scenario we can link to the soil and foundation also. Just link the paper as soil and the nib of the pen as the foundation or footing. So what happens when the foundation area is very less, it punches the soil and automatically your building settles down. But if you see uh, a footing or a foundation with a large area, it doesn't creates any problem to your soil. Okay, so when the whole plan area of the structure is given with a whole slab, then automatically your soil is not disturbed by overloading. So this is the type of footing called mat foundation. Okay.